Hello, my name is Alberto Picon. I'm the CIO of Todo En Cloud. We are a cloud company here in Spain. We have a presentation quite different from the other points of view I have already heard during this conference. We have presence here in Spain. We have already a point of view we would like to share with you, because one of the words that we like the most from OpenNebula is the agnosticism of their technology. They support lots of solutions, lots of technological solutions, and one of the things that we like the most is that approach. They do not take advantage of a concrete and a specific provider, and they provide support for lots of technologies, and that's one of the things that we like the most. They provide us the way to explore technology, to try to integrate it easily with our solutions, and that's one of the things that allow us to grow and to overcome the needs of our customers. One of the things why our customers choose us, mainly for the flexibility that we have. We are capable to most of the projects that we receive from Spain specifically are projects that want to migrate their infrastructure to our cloud environment, and we are capable to use our technology to move their projects to the cloud, and we manage them too. So we offer management services. We are able to migrate them services and manage from the scratch. So most of our projects are related with this approach. We like it to sell it like architecture as a service. We are a cloud architectures. So we like that concept, because there are lots of cloud providers, but sometimes they do not give the consultancy to adapt their solutions to their needs. One of the things that we have is we have disaster recovery services. We have 2 data centers in Madrid. We offer Tier 4, Tier 2 solutions to provide to our customers several requirements of their services. So one of the things of OpenNebula is that independent software technology approach. So for us, one of the things that we use the most from OpenNebula is to provide cloud bursting. The cloud bursting is a service that we provide to our customers, an easy way to scale their clouds to another providers, to Amazon, Azure, or even another OpenNebula through federation services. Due to this, we won this year the Eurocloud Award 2016. So we quite proud of it. Okay. I would like to show you a scene of our evolution, our technological evolution. We were using OpenNebula since version 3.2. We chose that this solution due to its flexibility, and what we like the most is that it was, as I heard lots of times here, it's an easy product, it can scale, it's lightweight, and it can run with very few resources. We're Zen guys, I'm sorry. How many of you are using Zen? Almost 1, 2, but we're a community at least, okay? So we like Zen a lot, but unfortunately, as the support, as you may know, is going down. So we knew this reality, and we knew we have to change in some way. We are 2 ZFS users. How many of you do you know this file system? Anybody of you use it? Okay, we are a community, right? So for us, this is our technology. We are very used to it, and we like a lot to use it. This kind of services, especially for ZFS storage clusters, is one of the difference we have from other cloud providers. Okay, so we have several changes here, and we have to face several limitations. For example, SEM virtualization. The SEM virtualization seems to be quite challenging lately because the SEM support is being more and more complicated. The live migration requires hardware, the same hardware from donor to the target hypervisor. Several distribution, I'm not going to say the name, removed the SEM support. I'm sure you know which one I'm referring to. So we have to make a change. ZFS has its own limitations. It has scale problems because to scale it is quite expensive. You have to know which are the limitations. For example, it depends on the slowest disk. To scale, it delivers performance degradation sometimes. And of course, the ZFS high availability solutions can fail. So we have to make a change. What changes have done from the last year? Since the last year, we tried to add full KVM support, and we tried to build our first cluster without losing the previous functionalities. So with OpenNebula, we made the effort to support all these technologies without losing the previous functionality, right? The self-design is quite complicated. I'm sure that many of you are trying to know, hey, I'm going to build my first ZFS cluster. Which are the components that will be required to build that kind of cluster? Maybe these are a summary of the required components. You will need 3 Ceph monitors. You will need at least 10 nodes to have a decent performance. You have to take into account services like Ceph FS that we are currently supporting. You will need two servers to provide it, and you will have to scale and to assign the correct journal partitions to your rotational disks and take several things into account, especially of how many disks do you assign to a journal disk, and the size of the journal partitions for a rotational disk, for the rotational disk. Okay. We needed a way to share data between virtual images. We used to provide this service using NFS from ZFS, and suddenly we need a way to scale, and we try to provide support of ZFS for our customers. It's currently under production since April the 21st, so it seems to be production ready. Unfortunately, the ZFS snapshots are not supported, but there are other ways to do things, and we try to give this a try. What have we mounted to support this technology was we created a cluster of NFS Ganesha with Samba and ZFS kernel drive active passive pacemaker cluster. Using this technology, it's possible to expose a ZFS service using NFS without exposing the ZFS core to the customer. The best thing of this is this technology runs the whole data structure. The inode structure goes directly on memory, so you have to scale your servers correctly to have the most metadata on the server memory to serve in a decent speed. Okay, so you can scale this service adding memory to the main server, right? I give you the commands to perform changes on the server directly, and to set up the layouts to assign directories to a pool. I give you here a procedure to install NFS Ganesha. it's not packetized in Ubuntu 14. You have to install it, you have to compile it, you have to configure it. This is the master Ceph configuration file you can use to test it. Whatever test you do will be nice to hear. And this is the systemd file you can use to provide the service, and several commands to make it work as an NFS server. Use an NFS ID map. With KVM, we had some problems too. One of them is to enable the live migration service between the hypervisors. We used Ubuntu 16, sorry for the typo, 16.0.04, and we had to disable AppArmor to make the live migration work. This is the procedure to disable it, so it's quite nice to have it. And we faced several problems with Ceph registered images and KVM service. Sadly, the VMs crashed without any reason. So we have to disable one of the new features of the Ceph version we were using, and we disabled using that command. It's very important because there is a bug recognized by Ceph, and it seems to be corrected in the new version. And OpenNebula has already added service to KVM to do QoS. And this is a hook we have written to provide network bandwidth limitation to the interfaces for versions of OpenNebula 4.14 and 5.0. You can use this hook to set QoS to the virtual machines during deployment at running state. Okay, you have a network bandwidth script. You take a value from the template and you apply the changes to the running state, or to the VM, to the whole interfaces, and you add that value on the template, and it will take this script and apply this bandwidth control to the bandwidth on running time. So, thank you very much.